Okay, this is part 2 final exam review. We talk about that there is 21 questions, 2 hours. I have shown you 10 points that you need to pay attention to particularly pay attention to Unit 1 and Unit 2. Now we're going to look at Unit 3 and that our units about the regression. So first one from Unit 3. What does confidence interval majority means? I mean, there were lots of questions about that. So if we claim that majority lies in that confidence interval, both lower limit, remember confidence intervals is about parameter, right? Here in this case, it's proportion, population proportion. So upper limit, both upper limit and lower limit should be greater than 50%, greater than equal to 50%, if you will. Then we can say that, yes, majority lies in there. Point 2, how do we construct confidence intervals? What tests do we use for props? What tests do we use for means? Okay, so you're ending up with slightly close numbers, but they're not correct because probably the question is about means and you're using z-test. No. Okay, the other point, how do we determine the minimum sample size by using the confidence interval? Well, this is the formula. I believe it should be in your note sheets in Unit 3. The other important thing, you would need to round it up. If you end up here, let's say you apply the given values and the end result is 98.1, but your answer should be 99. Okay? I don't think that you are going to have values that you are going to 98 exactly. That is very rare. So chances are very high likely you're going to end up with decimal. If your decimal, even if it is 0.01, you are going to round it up to the next whole number. Because the idea is you're designing a study and having one more data points, it's not going to hurt you rather than risking the whole study. Okay. Hypothesis test. So this is all about the confidence intervals. I need you to remember. Hypothesis testing. How do we read the results from the hypothesis testing? We're going to give you the context, and let's say that you do have a hypothesis testing that is about mean GPA of WakeTech students. I claim that in the STEM degrees that GPA is greater than equal to 3.8, and the null hypothesis could be this. Oh. And then we end up here, a p-value, let's say 0.001, and alpha is 1. So what do? You would say reject null hypothesis. And because you look at the context, you located the claim here. The researcher claims that students who are pursuing or who are planning to pursue STEM degrees have GPAs greater than 3.8. Well, the current situation will be less than or equal to. This is p-value. So what would be the result? We would reject null, and we would say that we have enough evidence to support the claim. So when you are interpreting, so decision is reject, interpreting is going back to the context. When you're interpreting the results, it is important where your claim is located. Okay? So what it means is that, let me just show you that screen. Okay. Yeah. Hypothesis testing interpretations. This is in our PowerPoint. find that box and remember which component of the box are we using. We're rejecting null and the claim is at H alternative, so we need to be speaking this language. Obviously, this is very generic one, this one that I have just taken in a red rectangle. The meaning should give that. Also remember that. Okay, so also another thing to remember, there are some questions. Select all true, select the true or the correct one. Okay, setting up a correct hypothesis. That's another important thing. Okay, what are you using? Are you using the parameters in the hypothesis testing? Are you placing the claim on the correct spot? Are you using the correct values against them? So you're going to make those choices from the given answer choices. All right, reading the output and decide the decision, what type of error happens. For instance, if you go back to this one, what the output will be reject null, right? In this case, if we reject null, it means that we can have a type 1 error. Type 1 error means that in reality, students who want to pursue STEM degrees had GPAs less than 3.8, but we rejected it. Consequence could be that thinking that our decision, our claim is correct, meaning students have higher GPAs than 3.8, we stop offering tutoring services to those students, or we stop offering STEM center hours for the students because they are safe, their GPA is greater than 3.8. So that will be the consequence. Another tricky thing, which I love, you are going to need maybe to calculate the test statistic, calculate the p-value. Sorry, let's go backwards. Calculate the p-value from t-test statistic. To be able to do that, you need to know the direction of your tests from the given hypothesis and which left tail or right tail test are you going to be using. So again, to our GPA problem, we can go back and look. So this is a right tail test. All right, and the p-value is not going to be given in that case when we give you only the test statistic, and we're not going to name that test statistic. We're just going to write their test statistics. We want you to know that, okay, this hypothesis is about mean, so test statistics should be t-test statistic. Okay, the claim is located there, so I'm looking at t-test statistics with right tail, and I need to calculate the p-value. Then we are going to be using this one here. Okay. Now, this is about Unit 3. Now, 3 questions about our small chapter. What does correlation coefficient tell? What does R tell? R tell either strong, negative, or strong, positive. This is neutral. If R is in this area, that will be strong, R value, which means greater than 0.5. If R value between -1 and strong positive, the between -1 and -0.5, that will be telling us strong negative. And we need to let the reader know is a part linear. Okay, so there are a couple of things that you need to mention: linear, strength, and direction. Direction is coming from, if R is negative, direction will be negative. If R is positive, positive. If R is greater than 0.5, closer to 1, that will be strong. If R is greater than, if R is between -1 and -0.5, again, it will be strong. All right, so now we also talk about the model, which is y hat will be equal to mx plus b, right? And decide the model is over or under predict. Well, over or under predict happens, we need to know the residual. So residual means the real data minus predicted one. So real means y, predicted one is y hat. All right, so for instance, let's say that we have some data in our hand, x and y values. Let's say x shows the sleeping hours, and y shows the efficiency. Okay, so among many data points, if people sleep 9 hours, let's say their efficiency constant is 5. Okay, so we're gonna create the model. Obviously, there are other data here. The model will be given to you. You're not going to be you're not going to need to enter the data in Excel and deal with that. So the model predicted, let's say, this. And 2. Okay. So when I plug in, according to this model, 5, I will have some y hat value. As a matter of fact, if we do that, 5 times 0.009 and plus 2, okay, so it means that when x is equal to 5, according to this model, y hat turns out to be 2.045. However, in the real situation, we're getting 5 for y value. So what it does, model is under predict. Okay, and the residual will be y minus y hat. Residual will be 5 minus 2.045, whatever that value is. Okay, this is all I wanted to say about the final exam. I wish you good luck, best of luck. You have enough time, take time. Use your time wisely and efficiently. Don't think that these are the only questions. Something else might pop up, but these are the basic things that I need you to know. This will be helpful for you if you pay attention to those points. All right, take care.